Welcome back. Welcome back to software engineering. Today we're going to continue learning about requirements, documents, eliciting requirements, specifying requirements. Many of you were stricken with woe when you saw your grade on the previous requirements documentation. Let me remind you that you need to make a sincere effort. Although the project is silly, in terms of how impossible it is, and the customer is a huge jerk, you still need to do it, and you still need to finish it. Let that be a lesson to you for the real world. No matter how silly the project or how dumb the customer, you still need to finish it, or you're not getting paid. If there's one lesson you learn in this class, it's that you always need to take your work seriously, no matter how terrible it happens to be on that particular day. And most days your work is not going to be nearly as terrible as this, so don't worry about that. I'm trying my best to make this process as simulatedly painful as possible. But again, as a reminder, put in a sincere effort, and you will do well in this class, but you gotta put some energy into it. You gotta make a good requirements document. You can't just copy what I got in the original specification and reword it a little. You gotta think about this. Really make these requirements happen. Alright, so if there's any other questions about that, let me know in either chat. Otherwise, let's move on to functional and non-functional requirements. We're starting off where we left off on that Chapter 4 slideshow from the Somerville book. Oh boy, it's got animations. Okay, so functional requirements versus non-functional requirements. Last time we grouped things in user requirements and system requirements. That's one way to split your requirements up. Another way, sometimes in the same document you'll split things both ways, is in functional and non-functional. Functional requirements are statements of what the system should do. These are statements about the services that the system is going to provide. They're concrete action statements about what the system does functionally, or a feature that it has, something that is describing the system's functionality. Non-functional requirements are constraints that the system has. So this is kind of more like a system requirement from last time, right? These are constraints on how to achieve those features, on how the services work, on how the functions are offered. They might be timing constraints, they might be development constraints, they might be legal constraints, they might be security constraints. We'll see a bunch of examples of non-functional requirements. But it's as simple as that. Functional requirements pertain to something the system does. Non-functional requirements, those pertain to a constraint that's imposed upon the system. And often, the non-functional requirements apply to the whole system rather than to an individual feature. So oftentimes, we want to pair our functional requirements with non-functional ones that are associated with them. And then, after we're done doing that, we have a bunch of these overall non-functional requirements that apply to the entire system. And we're not going to talk too much about domain requirements, but those are constraints on the system from the domain of operation. So we can just forget about those for now. We're just going to focus on functional and non-functional. So functional requirements, again, they describe the system functionality. Depending on the kind of software, depending on where the software is going to be used, you can have different kinds of functionality, different features. These requirements might be stated in a high-level way. We might state these in natural language. But they need to describe the system services in detail. We need to not leave room for ambiguity. Again, that's the name of the game in the requirements game, is not leaving room for ambiguity, is being specific and making sure that our requirements are understood, because this requirements documentation often serves as your contract of what you're obligated to do. So let's go back to that Mentcare system that we talked about last week and look at what we might call a couple of the functional requirements here. Let's say a user shall be able to search the appointments lists for all clinics. So remember that phrase. A user shall be able to search the appointments lists for all clinics. Remember that phrase and think about what it means to you. Think about in practice what a piece of software that allows you to search the appointments lists for all clinics looks like. I mean, what can it do? Is it a search bar? What do I type in there? What times do I put in there? All right, let's go into more detail. The system shall generate each day for each clinic a list of patients who are expected to attend appointments that day. Each staff member using the system shall be uniquely identified by his or her 8-digit employee number. So all three of these are features or functions of the application. The first two are obviously functions, things that the application does. The third one might better be described as a feature. It's not really a verb that the system does. The system doesn't have unique 8-digit employee IDs, I guess we could say, but it enforces this authentication mechanism by 8-digit employee number. So that's more like a feature than maybe a function. So functions and features, functional requirements are all about. But let's look at that first point again, right? That point wasn't precisely stated. Okay, we said search. We said search all clinics. That's ambiguous. Ambiguous requirements can be interpreted different ways, and when there's a difference between how the developer and the customer and the users interpret something, that creates a problem down the road. So think about that term search again. Maybe the user intended for that search to mean across all the appointments in all clinics and performed a search for their patient name. Maybe the developer intended it to search in an individual clinic, and then the user has to choose which clinic to search in some kind of drop-down box. Make it clear. It has to be specific. If you leave that kind of ambiguity open, you're going to end up doing more work down the road. So in principle, we want all of our requirements to be complete and consistent. We want them to be complete descriptions of all the facilities required, and we want them to be as detailed as they need to be. We want them not to contradict one another at any point. So we want there to be consistency, no conflicts between our requirements. And of course, we know intuitively that in practice this is impossible. Even for a very small system, let alone a very complicated system, achieving both of these completely is impossible. So we do the best we can to manage this complexity, knowing that we're never going to have a complete and fully consistent requirements document. But we want to do as well as possible. We want to be as complete and as consistent as we can be. All right, now let's look at non-functional requirements. Again, these are constraints, system properties, things like reliability, response time, storage requirements, I/O device capability, things about the system. You might want to, at this point, dictate non-functional requirements like what kind of system that you plan to run on. This would be something that the customer is obviously very interested in at the beginning. Of course, if you need a supercomputer, they're probably going to say no thank you. But you also might want to make even more specific non-functional requirements, like what language you're going to use, or what IDE, or what development method. Or you might not. If the customer doesn't insist, there's really no reason to peg yourself into a particular programming language or a particular IDE. If the customer doesn't care what language you use, then you don't necessarily have to specify. If it matters to the customer for some reason, then you should specify. You want to be as specific as possible with these non-functional requirements too, while also trying to give yourself, as the contractor that has to do the work, as much flexibility to complete it as possible. That doesn't mean you have to leave these non-functional requirements ambiguous, but you have to give yourself room to actually achieve what you're trying to achieve. If you make them too specific, if you say that your application is going to run on a Game Boy Color, you're never going to pull it off because it's too hard. Non-functional requirements can often be more important than the functional ones. If your application doesn't run on the client system, then it doesn't matter what features it has. It doesn't run on the client system. So those kinds of non-functional requirements are obvious. The system could be completely useless if you don't meet the non-functional standards. Let's look at how we might group non-functional requirements. Okay, the book offers this great hierarchy. We've got all non-functional requirements at the top, and then we break them into 3 basic categories: your product, your organizational, and your external. Your external are going to be things like legal, accounting, safety, ethical, regulatory requirements imposed by governments or agencies, getting certifications, whatever. Those are external. Organizational things might be things about the environment where the system operates, things about where the company that it operates under, the development requirements of the system, those kinds of things. Product requirements are the more obvious ones, like the security of the product, the dependability, how often is it permitted to crash, how stable does it have to be, what's the uptime on it. Usability requirements, how quickly can users use it, how much do they like it. Those things need to be measured in objective ways too, if we can. Look at that a little later. Efficiency requirements, what kind of hardware can it run on? How many frames per second should it get? If it's a game, that's especially important, but any real-time software needs some kind of efficiency requirements. Even not real-time software sometimes runs into efficiency problems, depending on what it's running on. So you've got your performance requirements, those are obvious. You've also got space requirements. If it takes up 25 gigabytes of hard drive space, that's going to make some people unhappy. So you probably want to set yourself a maximum. Do you want to set yourself a maximum of 20 megabytes? Again, probably not, because you're restricting yourself too much. Give yourself flexibility to come in under your memory budget. Non-functional requirements may require you to implement functional requirements as a result. So the non-functional requirements that you come up with might end up affecting the overall architecture of the system and forcing you to add features. So sometimes it's not that a functional requirement has a non-functional requirement associated with it, it's the other way around. So let's say you have a security requirement. You have to meet an organizational requirement or an external requirement, maybe like HIPAA compliance, or an organizational requirement like a hospital regulation. That forces you to impose a security requirement, also non-functional. So now your system has to meet a certain encryption standard. It has to have an authentication mechanism. People have to be able to sign in. So now people have to sign in. That's a functional requirement that you've added. You need to have some kind of login system. People need to have IDs. So just that non-functional requirement associated with a bunch of functional ones after the fact. Going back to those different classifications, we already went over those, the product, the organizational, the external, and the different hierarchies those fall under. So some examples for the Mentcare system, a product requirement. Notice the specificity here. The Mentcare system shall be available to all clinics during normal working hours, Monday through Friday, 8:30 to 17:30. Downtime within normal working hours shall not exceed 5 seconds in every one day. This is a common way to phrase your downtime. You can say your uptime in terms of a percentage. Your system is up 99.99% of the time. What is 99.99% of the time? It means in every 1,000 days you can be down 1, right? That's 99.99% uptime. What's 99% uptime? That means you can be down 1 in every 100 days. Wait, you get the idea. 99.99 is 1 in 1,000 days. 99% uptime is down 1 in every 100 days. I mean, 3 days a year your system's going to be down. Most people are unhappy with 99% uptime. 3 days a year of the system being down is pretty bad. But maybe the customer's okay with that. Who knows? Users of the Mentcare system shall authenticate themselves using their health authority identity card. So the organization has this card that they want their employees to use. That creates an organizational requirement. You need to work with the card that they have available. So your system needs to cooperate with that card. Now you have an external requirement to think about, a card that you have to deal with. So another system that your system has to interface with. Another external requirement, the system shall implement patient privacy provisions as set out in, and then some sort of regulation. So it's a regulatory guideline. Somebody asked if there's an industry standard. No, not really. I mean, this is something that different companies will do different ways when they execute their bids and when they sign their contracts. Every organization, public and private, wants to get their requirements handed to them in a different way. If you submit a contract for one organization, they probably want to see them in one format. Another company wants to see them in another format. Most companies are happy to accept format for many different kinds of contractors. The big firms, the big contractor firms, places like IBM, or the big third parties like Deloitte or something, those guys have tons of different forms that they use to fill out all their contracts and requirements. On the assignment today, I gave you one example of a requirements document from a real-world project that you can look at. The problem with all of these kinds of requirements documents from the real world is that they're really, really long. They're excessive for what we're doing here. So I've given you a simpler template that you can use. But there is definitely no standard template out in the world somewhere. Somebody else asked, when defining requirements, can I say, for example, we will have a health value for the player of 5, but it's subject to change? If you say that something is subject to change, then the customer can come back and ask you to change it. And whether the health value is 5 or 10, it doesn't really matter. So it's not something that you should be designating at this point, because that's more about how the system is going to work rather than what it's going to do. A better requirement would be to say that players have some health value, and then when it's depleted, something occurs. You would define the features rather than the specific details and the numbers and that sort of thing. So you wouldn't want to pigeon yourself into 5, and at the same time you don't want to make it possible for the customer to come back later and renegotiate different terms, especially when it wouldn't be advantageous to you, especially when it would be difficult. So in the case of something like just changing a health value, that should be pretty easy. And perhaps there is a non-functional requirement associated with that health value that it should be easy to change. There are examples of software where they've coded certain values, and just because of the way they've arranged it, it's very difficult to change those values. And that's a problem for the customer if they want to make tweaks. So it might be a non-functional requirement that that values for different properties need to be easy to change. But you don't want to specify a property that specifically, and you don't want to leave things that are difficult to do open for the customer to come back and say, come and change this for me. Non-functional requirements might be very difficult to state in language. So going back to like the one that we were just talking about, the health value thing. It's very difficult to state that you want to have your players with a health value and you want it to be easy to change that down the road. It's difficult to come up with that phrasing. It's really difficult to come up with that phrasing in a way that's specific. And the goal, usually when we're stating a non-functional requirement, is just to make some kind of general intention clear. So let's say we're talking about ease of use. Well, how do we make ease of use clear? How do we say users should be able to use our system? That's really difficult to do. We need to create non-functional requirements that are verifiable as much as we can, that are testable in some way objectively, so that when we go back to the customer and say we met this non-functional requirement because we can say why, rather than in case of ease of use, for example, saying, well, this interface is easy to use because it's easy for us to use. Well, and the customer can go back and say, well, it's not easy for me, so I guess go back and do it again until it's easy for me. And then you can be stuck in that forever until it's easy for them, which could very well be never. So as you make your goals and your non-functional requirements that are connected to those goals, make sure that you have concrete objective measures wherever you can to measure the success of meeting those different intentions. Let's say we have a goal. The system should be easy to use by medical staff, so we've been more specific there, and should be organized in such a way that user errors are minimized. All right, so this is basically a non-functional requirement about usability. And then we go back and we add another specification to that, how we're going to test it. We might put this on another line or a subpoint or something. It might be a bullet, maybe this in a table. Medical staff shall be able to use all the system functions after 4 hours of training. So we're concrete about who we're training, how long. After this training, the average number of errors made by experienced users shall not exceed 2 per hour of system use. Hopefully you haven't made this too restrictive. You haven't specified 4 hours when that's not nearly enough. Hopefully your system only needs 2. And give yourself as much flex as possible. Again, hopefully they don't make 2 errors per hour. Hopefully they make none. So, I mean, that's a pretty ambitious requirement there, but this is at least testable and you can verify it to the customer. Give me your medical staff. Let me train them for a bit. And then if they don't make errors, we're good to go. Here are some other metrics by which you might be able to specify concrete goals for your non-functional requirements. So if you have a system speed in mind, you might talk about transactions processed a second, the response time of the user interface, the screen refresh, the frame rate. If it's a size thing, you could specify it just in terms of megabytes that your application consumes. Maybe if it's a hardware product, in terms of the number of ROM chips that's required to install or the size of those associated chips. Maybe you have RAM usage in mind too, maybe not just memory in the system permanently. Maybe you have database memory in mind too, how much cloud storage you're going to use. Training time for ease of use, number of help frames. You could do Likert scales of how much the users like to use the software or the product. Different kinds of objective reviews like that. Have some kind of test group that okays your product, but obviously make sure that they're not a test group that is so well connected to the customer that they get absolute authority to keep making changes whenever they aren't satisfied. For reliability, you could designate like a time to failure, an uptime guarantee, probability that it's going to be unavailable on a given day, how often rate of failures are permitted to occur. No system is failure proof, so you have to specify some kind of rate of failure for almost any system. The tighter you make it, the harder it'll be for you to meet. In many cases, people are satisfied with 99% uptime. If they're building the space shuttle, they're probably not. They're probably only satisfied with 6 nines uptime, but that's not most projects. Robustness, portability, all these different kinds of non-functional properties. And lastly, let's look at a little bit of the beginning of the requirements engineering process, because that's what we're doing here today and this week and the next week too, before we finish with this. We're trying to solicit our requirements and then commit them to a master document here. So we got 4 basic activities that come into play when we're trying to make a requirements document. We got our elicitation, analysis, validation, and management. And in practice, this is usually an iterative and interactive activity that involves a lot of back and forth with the customer and stakeholders and evolves over generations of being done over and over again in steps, so it's not something you would do all at once like we're doing. In practice, it's more like this. It's a spiral. You start in the center, you try to draw out some business requirements, you see if they're feasible, you try to elicit some user requirements, you specify them, you draw up a little prototype, you get some system requirements, and on the spiral goes. But we obviously don't have the opportunity to do that, keep going back and forth to the customer and everything. So let's talk about how requirements elicitation would work so that you can take advantage of it a little bit today if you want and ask the customer or maybe even some of their potential end users for information. So the elicitation or the discovery phase involves the technical staff, that is you, working with the customers and other stakeholders to basically figure out the system's functionality and operational constraints. So you might end up talking to end users, managers, engineers, experts in the domain, so maybe nuclear physicists or whoever it is that happens to be an expert in your application, unions, whatever. You're talking to stakeholders, maybe even not stakeholders, maybe even people who just know a lot about that kind of system to figure out what kind of functionality it should have and what kind of constraints it's going to fall under. This process might be really short initially, it might be something that you keep going back to, but it's something that you're typically going to start with in some form or another. So you're working within that range of stakeholders to find out information about the domain in which your application runs, the kinds of services it should provide, and what's expected of that kind of application. So maybe there's an industry standard, maybe not. Maybe people just have expectations they want you to meet, maybe not. This is your chance to find out. So if you have the opportunity today, feel free to ask the customer to talk to some of these external stakeholders if you can think of any. You probably specified some last time. Maybe you'll take advantage of today to talk to them. Okay, and then of course that runs into problems, right? Stakeholders don't know what they really want. Sometimes they express requirements in terms that are not really translatable to you. Sometimes they have conflicting requirements. They want different things, especially between, say, managers and end users. Maybe end users of a software don't want all of their behavior to be constantly tracked. Managers usually feel a different way about their employees. So those are some obvious examples where there's going to be a conflict. You've got organizational and political factors at play there, and the requirements will change, of course, many times. As we know, in agile development, requirements will emerge, requirements will fade away, and the business environment may change substantially, so don't get too committed to the first information that you get, essentially. That's going to be it for today. We're going to get into it then, and I'll see you in Discord. The assignment that's up today is due at the start of class next time, so you can feel free to work on it after class in the intervening day and a half or so. Okay, see you in Discord.